I wanted to talk about this concept known as guard clauses or early returns. And this is a very special concept that will help you improve your code quality a lot. It's basically based in reducing the amount of nesting that goes into a function. Because sometimes when we create functions, we end up with a lot of nesting because of the many conditions that the function can have. And this nesting can make the code really hard to read and hard to follow and hard to understand. So with this new technique that you're going to learn, you're going to improve your quality a lot. So if you look at this class, the string encoder, we have a nightmare of a method. You see, we have all this nesting going on, and we want to refactor this because it's really unmanageable. Let's talk about what the function does. This function receives a string and it encodes it with an algorithm called the length encoding. So for example, if I send the string A, 4 A's, the encoding for that would be A4, so 2 characters. And if I send A, B, it would be A3, B3. So the character and all the times is repeated. But if the character it appears only once, then the encoding will be only the character and there will be no number. So only in the cases where the character is more than once, we will add the number. So that is the code, and the code has some special conditions here. So for example, if the input string is null, then we don't want to do something. So we check that the string is not null, and we check the size of the string as well. So it has to be greater than 5 and it has to be lower than 100, and then it has to match this particular regular expression, which actually means that it doesn't contain any numbers. So the string can't have numbers. Here's the whole encoding logic. That's fine. Okay. So what I would like to do first is, I've noticed that this and this section of the code are the same. So I'm going to extract them. This is basically appending the result. So I'm going to say append current to result. And IntelliJ is smart enough to realize that this code is repeated, so it will replace it twice. So now it's a little bit more readable, but still we have this structure here, sometimes called the pyramid of doom. And you can tell why. This really is hard to read. For example, if the string is null, then we have to go all the way down here to figure out what happens. We'll throw an exception. Again, if the string doesn't get inside this range, we have to go all the way down here and see what happens in that case. So we have to have a very good track of where the else is for this if. And thankfully, these tools like IntelliJ, they can tell you where the if ends and the else begins. But if you didn't have this, it would be a nightmare. So let's just do a whole lot of refactoring. First, let's start with this. So I'm going to implement the guard clause. What is the guard clause? It's basically an if that will terminate the function either with a return or with a throws, but it will terminate the function early so that the rest of the code can then be executed as if this condition is not met. For example, how do I implement the guard clause here? I'm checking here if this is null, if the s is null. So I could flip the condition and say, instead of doing something if it's not null, what I want to do is I want to terminate the execution if it is null. So I'm going to say if s is null, so equals null, then I will do whatever I was going to do in the else clause. Throw this, right? So this is how you would write the guard clause. Now, a pro tip here, I would even put this in the same line of the if to make it even more concise. And I will move this if to the top of the program. So now I can remove this, because if this condition is met, if s is null, this will terminate, and that's it. So now I have one if less to worry about. So now I can do the same with this one, for example. Now I have to flip this one. How do I flip this one? So this is greater than 5, so I could say it's lower than 6. I can flip this with an or instead of an and in here I can flip the condition again and 99. So if s length is lower or greater than 6, and if s length is greater or lower than 99, then what do? We throw an exception as well. And we can remove this and this and this. So what else are we missing? I think here we had to use 5 and 100, sorry. So now it makes sense. Now we're keeping it all the same. And now we have this if. So first I'm going to extract this into a method to make it more readable. So I'm going to say contains numbers. Now it's easy to understand what this is doing. And now I'm going to flip the condition as well up here. Instead of saying doesn't contain numbers, I'm going to say if it contains numbers, then I will throw an exception saying illegal argument exception, string contains numbers. So now I can get rid of this other if and all this part here. So now I have only one if in my whole function, because these ones I can disregard. I could even put them, all of this, into a method and just say validate input. And this, because these are throwing exceptions, this will terminate the program early. So now, do you see how concise this method is? It's really easy to understand now what's happening. We're basically iterating the string, and we're counting if we find the same character, and if we have a different character, we append the character to the result with the count, and that's it. So I can run this main program and it's encoded. So this is everything that there is about God classes. It's really useful. Um, it's a very useful technique for removing unnecessary nesting in our operations, in our functions. So I really recommend that you use it, and your code will improve and your colleagues will love it. So that is all for today. Thank you.